Hi, Mrs. Brown here. I wanted to come on and go through a little bit on research in AP Psychology, and specifically I wanted to talk about statistics in research. What can we learn from looking at data within a research study, and how can we use statistics to examine research within psychology? All right, so as we get into statistics, it's important for you to understand there are two different categories of statistics. So there's descriptive and inferential. So descriptive uses analysis of numeric data. So if we said 25% of Americans eat fast food daily. Now, I don't know if this is true or not. This is just a statistic that I made up. But we know it's a descriptive statistic because it uses a number. That 25% is numeric. Inferential is used to make inferences from, based on non-numerical data. Okay, so it says based on polling, Trump will win the election. This is just a silly thing that I made up because we don't know the actual data on this yet, but there's no number. It's just an inferential statistic. All right, so within descriptive statistics, which is the type that uses that numerical data, we have two different types of statistics. So we have measures of central tendency and we have measures of variation. So our measures of central tendency are going to be mean, median, and mode, our three M's. And we're going to use these to gather some data about our statistics and what that can tell us. And then our measures of variation, how do the scores in general, or the data in general, vary from the mean, from the average score? We can use range and we can use standard deviation. All right, so for central tendency, we can use median, mode, or mean. Okay, so median is the middle number. So what we want to do is anytime we get a set of data, set of scores, we have all these numbers, we're going to first line them up from the lowest number to the highest number. So if we had this set of data, we would start by rearranging the data, putting them in order, starting with 2.2, 2.3, 3.4, etc., going all the way up. Then what we could do is just count from the outsides in and find the middle number. Now, one question is, how do I do this if there is no middle number? Well, what you would do is take the two numbers that are in the middle then and add them up and divide them by 2. Okay, so that would be then your median, okay, the middle. Then we get the mode. So I always like to think of row, row, row your boat, and I think mode's the most common value. So that helps me. So you want to look for numbers that repeat more than other numbers. That's going to be your mode. So in this case, we have 3 9.6s. No other numbers repeat 3 times. We know that is the mode. Okay. And then we get to the mean. And I always joke that the mean is mean because it makes you do the most work. So for the mean, you have to add up all the numbers together. So we would have them lined up, but we would do 3.4 plus 4.8 plus 8.4, etc. Add them all up, you'll get a number. And then you want to divide that by the total number of numbers. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So we would want to divide by 10 in this case, and that's going to be our mean. Our mean is the average. Okay, so a couple of things to think about with central tendency. The mean score is most influenced by extreme scores, or what we call outliers. So if we had a lot of scores that were kind of near each other, but then we had some really, really low scores, or we had some really, really high scores, those are going to affect the mean more than they're going to affect the median or the mode, usually. So that is something to think about. If we're trying to eliminate the possibility of outliers or extreme scores influencing our data, we would want to use the median instead of the mean. Okay, so for example, when I look at test scores, if everybody did really well, but 1 or 2 kids got a really low score, that mean, that average is going to be lower than it would be if I took the median. So, just those 1 or 2 scores can really impact the average of a class. So that's something to think about. Variation is another thing that we can look at. So when we are looking at variation, we want to know how the scores in general vary from the mean. So this is what I was just talking about. We want to know, just by looking at a measure of variation, are all the scores pretty close together, or do we have those outliers, those extreme sets of data that are pulling or skewing our distribution of our scores in one direction or another, right? Because that would be important for us to know if we did have those extremes. So one measure of variation we can use is standard deviation. Okay, so we want to look at how the data is deviating from the mean. So if we have a small standard deviation, that's good. We like to see that. That means that the data does not vary, doesn't deviate very much. We don't have those extreme scores, those outliers pulling our data, skewing our data. If we do have a large standard deviation, then that tells us we do have a big distribution of scores with potentially extreme scores, either high or low, pulling our data and making it, more deviant from the mean scores. How do we find the standard deviation? Well, for all of you math folk out there, here is a formula for you, okay? Or what you can remember is that standard deviation is the square root of the variance. Standard deviation is the square root of the variance. Why is this helpful? Because usually, not all the time, but a lot of the time when you are calculating standard deviation in AP Psychology, they might give you the variance. And then you would just have to figure out it's the square root. Or they would say, calculate the variance and you can keep it in the square root of that number. So hopefully this helps you. For those of you that love mnemonic devices, I do have this tune to I'm a Yankee Doodle Dandy. So it goes, I'm a standard deviation am I estimate the average distance from the mean across a group of scores. Dun, 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 dun. I'm a standard deviation am I. Subtract the mean from each square and add them up. Divide by n, take the root, and that's a standard deviation. Yeah! So there you go. You can memorize this little tune if it's helpful for you. All right, so like I mentioned, we want to not only understand, oh, by the way, the other measure of variation would be range. Okay, so standard deviation and range is super easy. All you have to do is take the highest score and subtract from that the lowest score. All right, so how can we visually show our data? Remember, for correlational studies, right? I told you that we can visually see our data on a scatter plot. Okay, well, when we're looking at statistics and trying to look at distribution of scores, so understanding what that variation means, we use a curve. Okay, so what we like to see is what we call a normal curve. All right, a normal curve is sometimes called a bell curve because it looks like the bottom of a bell. So imagine you had your handle, ring, ring, okay, and that kind of looks like a bell, so that's why sometimes you'll hear it called a bell curve. A normal curve means that we have a certain percentage of our scores within a certain number of standard deviations of the mean. Okay, so our mean on a curve is in the middle. All right, and if we had scores that were really extreme and we're pulling our curve too high, then our curve would be skewed, or too low and our curve would be skewed. What we like to see is we don't have a lot of variation, and so we have a normal distribution of our scores, and we need to memorize what this looks like. Okay, so here we go. This is absolutely non-negotiable. Gotta know it, gotta memorize it, be able to draw it at the drop of a hat, because there'll be lots of questions on your AP exam, potentially FRQs, your unit tests, where they're asking you various things about this, okay? So they may give you like a problem that goes with this, or some sort of analysis where if you know it, you would be able to get it right. All right, so here's our normal distribution, normal curve, bell curve. We have our mean, okay? And a lot of times they'll use this with intelligence, and we're going to talk about intelligence later this year, and they'd say if the average intelligence is 100, you know, what would our normal curve look like? And we'll go through that later this year. But you'll have your mean, okay? And so what you need to understand is that on a normal curve, 68%, I know this might be hard to see, this is 68% are within one standard deviation of the mean, okay? So we have 34% here and 34% here. Why? Because 34 plus 34 equals 68. Okay, so we divide it in half. So one standard deviation above and one standard deviation below. If it's saying just one standard deviation below, we know it's 34%. If it's, you know, above, same thing. If it's within one standard deviation above or below, 68%. Okay, within two standard deviations above or below is 95% of the scores, okay, on a normal curve. So what that means is we can look at this and say, okay, all of these scores from this line all the way over to this line, this is 95% of the scores. Okay, so if we were to divide that in half, we know we can get that second standard deviation is 13.5% on each side. Okay, so then we know that what's half of 95. 47.5, so 34 plus 13.5, 47.5 below and 47.5 above, 95% of the scores within two standard deviations of the mean, okay? Then within three standard deviations of the mean, 99.7% of the scores, okay? 99.7% fall within those three standard deviations. So we know what, like 49.85% or something below and the same above, okay? So we need to be able to know everything and anything about this chart. And I would just say you need to start memorizing 68, 95, 99, 7, 68, 95, 99, 7, 68, 95, 99, 7. 1, 2, and 3 standard deviations above and below the mean. Okay, so convert this bad boy to memory. All right, the last thing I want to talk about with you today is statistics and probability. All right, so what can we use these statistics for? Like, what does this tell us in terms of our research? Well, what we like to see is that from our data and the things that we have analyzed in our research, that it is statistically significant. That it's statistically significant. So what does that mean? It's statistically significant. It means that if somebody else were to repeat that study, because reliability is repeatability or replication of the study, right? If somebody else was to repeat it, because the data was statistically significant and it was not due to chance, probably because we've set up our experiment in all the right ways. We have, you know, had random selection and random assignment. We have probably a double blind. We have a control group, experimental group. We've limited confounding and extraneous variables, all the things, right? We've gotten statistically significant data, and that means the probability that it's due to chance that we've gotten our results is very low. And so if somebody were to repeat it because it's a reliable research study, they will get the same results. And that is what we like to see with that statistically significant data, which is really hard for me to say, statistically significant. Okay, so we like to see that the probability due to chance is low. How low? We like to see it be less than 5% due to chance. Okay, so we want to know that if we repeat this again, that we're 95% sure or higher that we're going to get the same results because it's not due to chance. Okay, so probability, P, if our data is statistically significant, probability due to chance should be less than 5%. So we know that the probability it's not due to chance should be 95%. Okay, we want 95% not due to chance. What does that tell us? Okay, we want that 95% of cases to fall within 2 standard deviations of the mean. Okay, if our data is not statistically significant because our probability due to chance is greater than 5%, or our probability not due to chance is less than 95%, then that tells us there's been some sort of problem in our research. It's not reliable, and we're gonna have to go back and figure out where we went wrong, because otherwise if somebody repeats that, they're probably not going to get the same result, and that's not a good thing. So we want to make sure that our statistical information is telling us something that is statistically significant, and that if somebody else repeated the research in the same way, they have the same operational definition of variables, and they've set it up exactly the same way, that they're going to get the same results. All right. That's it for now. I hope this was helpful for statistics, and I'm going to sign off. Thanks. But if you're watching this during synchronous class, your class is not over, so keep doing your classwork. Okay, thanks. Bye.